In today's lesson, we're going to learn some new proofs that will enable us to prove that lines are parallel. And these theorems will actually be the converses of the corresponding angles postulate and the other theorems that we learned in the last lesson. So the first one is the corresponding angles converse, and it says if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Okay, so the picture is we have these two lines here. They're cut by this transversal, and they're telling us that angle 6 is congruent to angle 1. And since those are corresponding angles, I could then conclude that line J is parallel to line K. All right, then we have the alternate interior angles converse that says if two lines are cut by a transversal, so that alternate interior angles are congruent, then those lines will be parallel. Then we have the consecutive interior angles converse that says if two lines are cut by a transversal so that consecutive or same side, right? We also call them same side interior angles are, these aren't congruent, right? They're supplementary. These would have to be supplementary, and I'm just going to abbreviate it because my blank is too short. Then I know that those lines would be parallel. So in this picture, angles 1 and 2, same side or consecutive interior angles. If I know that they're supplementary, then I know that those two lines are parallel. Okay? So, and then finally we have the converse of the alternate exterior angles theorem that says the two lines are cut by a transversal so that alternate exterior angles are congruent. Then we know that those lines are parallel. All right, so let's hop right in here and prove one of these theorems. We could prove them all, but we're going to just prove this last one here, the alternate exterior angles converse. So of course, as you know, when we're proving one of the theorems, we can't use that in our proof. So we just got to remember to stay away from that. So get your two columns set up. Of course, we know our first step is what's given. Angle 1 is congruent to angle 2. All right, so I know that since I'm trying to prove those two lines M and N are parallel, I'm going to have to use one of the converses. All right, so let's see. I know, what else do I know? What else do I know from looking at this picture? Oh, I see something. I know that angle 2 is congruent to angle 3, right? How do I know that? Because they're vertical angles, and the vertical angles theorem tells me that. Okay, so now I can draw a conclusion based on statements 1 and 2, and that would be that angle 1 is congruent to angle 3. And of course, that's the transitive property of congruence. And since angles 1 and 3 are congruent, what kind of angles are those? They're corresponding angles, right? So since corresponding angles are congruent, then I know that lines M and N are parallel. Because remember, I learned the corresponding angles converse before I learned the exterior angles converse. Alternate exterior angles converse. So I can use that. So now I'm going to say M is parallel to N by the corresponding angles converse. The key thing you want to remember here is that whenever what you're trying to prove is that two lines are parallel, the reason is going to have to be a converse if I'm using one of these four. There are some other theorems coming up later, but for now we're going to use a converse. Okay, let's see what we have next. Find the value of x that makes P parallel to Q. All right, well, these are alternate interior angles. So if P is parallel to Q, then I know those two angles are congruent, and therefore their measures would be equal. So I'm just going to set those equal. Solve for x. So let's see, that's a negative 3x equals negative 36. So x is going to be 12 right there. All right, on my answer sheet I had 18, but it's definitely 12. Double check me there, make sure I didn't make an arithmetic mistake. Okay, we've got two more practice problems here. Why don't you pause and do these two, come back and check them. All right, so in the first example there, I can see that those two angles are alternate exterior angles, and for P to be parallel to Q, alternate exterior angles would have to be congruent. So I set the two measures equal and got x equals 10. The next example, I'm given consecutive interior angles, and I know that for those two lines P and Q to be parallel, those consecutive interior angles would be supplementary. So I set up my equation. I get x equals 5. Let me know if you need help on that next time. Okay, what do we have now? Decide whether AG is parallel to CE. Okay, I got a lot going on here, so I'm going to highlight these two lines I'm talking about. Here's AG. Here is CE. And of course, for those two lines, this is the only option I have for a transversal. So I'm going to have to find an angle pair and see if they have the proper relationship to make those two parallel. So let's see what I know here. What do I have? I've got this angle here and this angle here, right? Those would be alternate interior angles, correct? Alternate interior angles, and of course they have to be congruent if AG is parallel to CE. So let's just see, I got 46 and 67 on this side, so that's 103, and I got 67 and 50 on the other side, which is 117. So AG is not parallel to CE because alternate interior angles are not congruent. Okay, now we got to look at the other two. So let me erase this. You can just use a different color if you want to. BH, here's BH, and I'm trying to see if it's parallel to DF. And of course this would have to be my transversal again. It's the only line that cuts both of the lines I'm looking at. So what do I have here? I've got 67 and this, right? Nope, nope, nope. 67 for one and 67 down here too, right? So in this case, the alternate interior angles are congruent. So BH is parallel to DF. I can't encourage you enough to use some colored pencils or highlighters or something on a problem like this, or it's going to be very hard to determine if the lines we're talking about are parallel or not. Okay, here's one for you to practice. No, two for you to practice. So you go ahead and pause and try to do these and come right back and check. Okay, so in our first problem, I highlighted my lines, I highlighted my transversal, and I can see the angles that I'm going to be looking at are these two consecutive interior angles. And what has to be true for line BA to be parallel to DE is that those two angles have to be supplementary. So that means 90 plus 45 plus 45 has to be 180, and of course it is, so we know that BA is parallel to DE. And then in our next example, highlight my lines, highlight my transversal. I can see this time that I'm given alternate exterior angles, and indeed, they both measure 105, which means they are congruent, which means BA is parallel to DE again in this example. Okay, what's next? Oh, another problem. Well, we'll just do this together. This is the last one of the lesson. Which lines are parallel if angle 1 is congruent to angle 2? Well, clearly, those are corresponding angles that are created by these two lines here in this transversal, right? So that means A has to be parallel to B. And again, guys, that would be more difficult for me to see if I didn't highlight that with a different color. Okay, let me go do the second part. 6 and 7. 6 is congruent to 7. Once again, they're corresponding angles. They're corresponding angles for lines L and M and transversal B, right? L and M, so that means L is parallel to M. And finally, 6 and 1. Let's look at 6 and 1 here. 6 and 1. 6 and 1 do not have two lines and a transversal in common, so that doesn't tell me anything. This doesn't tell me, I mean, just knowing that 6 is congruent to 1, it doesn't tell me that there aren't some lines that are parallel, but I cannot make a conclusion just knowing that angle 6 is congruent to angle 1, so no conclusion there. And finally, I want you to do something extra here tonight. This is a pretty short lesson. I want you to get a little more proof practice. So I want you to go to page 162 in your textbook. And do a 2-column proof. For problem number 40. All right, I want to see that on everybody's paper tomorrow. When we come in, we'll talk about it, we'll check it, and we'll see you next time.